National Electrical Code Article 440.22 requires flexible connections to be used between fixed portions of wiring and moving equipment. This requirement aims to mitigate the risks associated with vibration, movement, and potential physical stress on electrical connections. Article 440.22b further specifies that the flexible connection must be of an approved type, suitable for the purpose and location in which it is installed. This ensures that the flexible connection can withstand the environmental conditions and operational demands of the application. NEC interpretations provide additional guidance on the application of these code requirements. Specifically, NEC Interpretation 440.22 clarifies that the code requirement for flexible connections indeed applies to air compressors. This interpretation removes any ambiguity and confirms that air compressors, due to their inherent vibration and potential for movement, fall under the purview of Article 440.22a. NEC Interpretation 440.22b states that heavy-duty flexible conduit can be used for the connection between the electrical supply and the air compressor. This interpretation identifies a specific type of flexible conduit that is deemed suitable for this application. Heavy-duty flexible conduit offers enhanced protection against physical damage, environmental factors, and the stresses associated with continuous vibration. Even if the air compressor is mounted on vibration damping pads and has an equipment grounding conductor or EG in place, it may still be necessary to use flexible conduit to prevent damage to the electrical connection. While mounting pads can reduce the transmission of vibration to the surrounding structure, they do not eliminate it entirely. The residual vibration, combined with any potential movement of the unit, can still cause stress on the electrical connections. Flexible conduit provides an additional layer of protection against these stresses, ensuring a more reliable and durable electrical installation. Flexible conduit also provides additional protection against physical damage to the conductors. This is especially important in areas where the equipment may be exposed to impact, abrasion, or other forms of mechanical stress. By encasing the conductors in a flexible conduit, the risk of damage is significantly reduced, which contributes to the overall safety and reliability of the electrical system. It is considered good practice to use flexible conduit when connecting a 25 horsepower air compressor, even if it is mounted on pads and has an EGC. This practice is based on the NEC requirements and interpretations, as well as sound engineering principles. By incorporating flexible conduit into the electrical installation, one can ensure a more reliable and safe electrical connection for the air compressor. To elaborate further on the technical aspects, the selection of appropriate flexible conduit is crucial. Several types of flexible conduit are available, each with its own characteristics and applications. Firstly, flexible metal conduit, or FMC, is a common choice for general-purpose applications. It is constructed from a helically wound strip of metal, which provides flexibility and mechanical protection. FMC is relatively easy to install and can be bent to accommodate various installation configurations. Secondly, liquid-type flexible metal conduit, or LFMC, is similar to FMC but includes a liquid-tight jacket. This jacket provides protection against moisture, oil, and other environmental factors. LFMC is suitable for use in damp or wet locations where the electrical connections may be exposed to liquids. Thirdly, flexible metallic tubing, or FMT, is a thinner and more lightweight version of FMC. FMT is typically used for shorter runs and in applications where flexibility is paramount. It is not as robust as FMC or LFMC and may not be suitable for applications where physical protection is a primary concern. Fourthly, liquid-tight flexible non-metallic conduit, or LFNC, is a non-metallic conduit that provides liquid-tight protection. LFNC is often used in corrosive environments or where electrical isolation is required. It is available in various materials, such as nylon and polyvinyl chloride, or polyvinyl chloride. When selecting flexible conduit, it is essential to consider the environmental conditions to which the conduit will be exposed. Factors such as temperature, humidity, exposure to chemicals, and potential for physical damage should all be taken into account. The conduit should be rated for the specific environmental conditions to ensure that it will provide adequate protection. In addition to selecting the appropriate type of flexible conduit, it is also important to ensure that the conduit is properly sized. The size of the conduit should be sufficient to accommodate the conductors that will be installed within it. The National Electrical Code provides guidelines for conduit fill, which specifies the maximum number of conductors that can be installed in a given size of conduit. Following these guidelines will help to prevent overheating and ensure the safe operation of the electrical system. The installation of flexible conduit should be performed by a qualified electrician who is familiar with the National Electrical Code and local electrical codes. The electrician should ensure that the conduit is properly supported and secured, and that all connections are made in accordance with the code requirements. Proper installation is essential to ensure the long-term reliability and safety of the electrical system. Furthermore, the equipment grounding conductor, or EG, plays a critical role in providing a safe path for fault current to return to the source. The EGC should be properly sized and connected to the air compressor and the electrical panel. This will help to protect against electrical shock hazards and prevent damage to equipment in the event of a fault. In addition to the NEC requirements, it is also important to consider any local electrical codes or regulations that may apply. Local codes may have more stringent requirements than the NEC, and it is essential to comply with all applicable codes. Local authorities typically inspect electrical installations to ensure compliance with these codes. Regular inspection and maintenance of the electrical system is also crucial. This includes inspecting the flexible conduit for any signs of damage such as cracks, abrasions, or corrosion. Any damaged conduit should be replaced promptly to prevent potential electrical hazards. The connections at both ends of the flexible conduit should also be inspected to ensure that they are tight and secure. Loose connections can cause overheating and potentially lead to electrical fires. The air compressor itself should also be regularly maintained in accordance with the manufacturer's recommendations. This includes checking the motor, belts, and other components for wear and tear. A properly maintained air compressor will operate more efficiently and reliably, and it will also be less likely to cause electrical problems. In summary, the use of flexible conduit for connecting a 25 horsepower air compressor is a recommended practice based on the National Electrical Code and sound engineering principles. Flexible conduit provides protection against vibration, physical damage, and environmental factors, ensuring a more reliable and safe electrical connection. The selection of appropriate flexible conduit, proper sizing, and correct installation are all essential to ensure the long-term performance of the electrical system. Regular inspection and maintenance will help to identify and address any potential problems before they can lead to electrical hazards. It is important to remember that electrical work can be dangerous, and it should only be performed by qualified individuals who are familiar with the applicable codes and safety procedures. When in doubt, it is always best to consult with a licensed electrician to ensure that the electrical installation is safe and compliant with all applicable regulations. For example, Table 300.5 provides guidance on the minimum burial depths for electrical conductors and cables. This table specifies the required depth based on the voltage of the system, the type of wiring method used, and the location of the installation. Following these guidelines will help to protect the conductors and cables from physical damage and ensure the safe operation of the electrical system. Article 310.15 provides guidance on the allowable ampacity of conductors. Ampacity is the maximum amount of current that a conductor can carry continuously without exceeding its temperature rating. The allowable ampacity of a conductor depends on several factors, including the size of the conductor, the type of insulation, and the ambient temperature. This article also contains correction factors for ambient temperature and the number of current-carrying conductors in a raceway or cable. These correction factors must be applied to the base ampacity rating to determine the actual allowable ampacity for the specific installation. Article 250 provides comprehensive requirements for grounding and bonding. Grounding is the process of connecting electrical equipment to the earth to provide a low impedance path for fault current to return to the source. Bonding is the process of connecting different metal parts of an electrical system together to create an electrically continuous path. Proper grounding and bonding are essential for electrical safety, as they help to protect against electrical shock hazards and prevent damage to equipment in the event of a fault. Article 430 covers the requirements for motors, motor circuits, and motor controllers. This article provides guidance on the selection of overcurrent protection, motor disconnecting means, and motor control circuits. It also includes requirements for motor starters, overload protection, and motor branch circuit conductors. The NEC is updated every 3 years, so it is essential to stay up to date with the latest edition. Changes to the code can impact electrical installations, and it is important to be aware of these changes to ensure compliance. Many resources are available to help electrical professionals stay up to date with the NEC, including training courses, seminars, and online resources. In addition to the NEC, many other standards and regulations may apply to electrical installations. These standards may be developed by organizations such as the Institute of Electrical and Electronics Engineers, or IEE, the National Fire Protection Association, or NFPA, and Underwriters Laboratories, or UL. It is important to be familiar with these standards and regulations to ensure that electrical installations meet all applicable requirements. Continuing education is essential for electrical professionals to stay up to date with the latest technologies, codes, and standards. Many organizations offer continuing education courses and programs for electricians. These courses can help electricians to improve their skills and knowledge and to stay compliant with the latest regulations. In conclusion, ensuring a safe and reliable electrical connection for a 25 horsepower air compressor involves careful consideration of the NEC requirements, proper selection and installation of flexible conduit, adherence to local codes, and regular maintenance. By following these guidelines, it is possible to create an electrical installation that is both safe and compliant with all applicable regulations.